Hey there, CE508. In this video, we're going to learn about the process of plastic pipe installation. This project is being done right here at the University of Kentucky, and it will assist in the UK parking structure number 8 expansion. We're going to show you how it's done, how it's manufactured, and other related elements to the project. So let's go ahead and jump in. First, we have the CAT 336F doing the heavy excavating. This is done to develop our trench for the pipe. In some cases, you'll run into some rock that you need to hammer out, which can sometimes get lengthy. Now what we see here is the soil and rock being loaded up to be hauled off. Oops, missed a little bit. Once the truck pulls off, they go back to excavating. We see the skid steer here making trips back and forth to cover up the pipe that was previously laid. For this project, they chose to make the backfill up to surface with gravel, which is why they have no need for the soil that they excavate. Before they lay any pipe, they first place a pipe laser in the manhole and shoot their grade line across the trench. This ensures that the pipe is sloped enough to where water is always drained to where it needs to go. Now, let's get to the fun stuff. The laborer is getting the pipe in position from their stockpile to be hooked into the excavator arm. They do this by tying a strap around the pipe. That strap is then placed onto the hook being attached to the excavator arm here. As we will see in the next clip, the pipe is easily lowered into the trench without any significant damage. This also helps add to the safety of the labor, as one of these pipes weighs anywhere from 150 to 200 pounds. Near the time of placement, the laborer will add PVC lubricant on the inside of the pipe to help seal the rubber gasket, which keep these pipes locked tight. They will do one last slope check for safe measures, and now they will begin backfilling the pipe with gravel. Normally, this will only be about a foot above the pipe. One of the final steps is to drag a roll of green warning tape above the pipe. This tape serves as an indicator that sewage pipe is nearby for any future excavation. Talk about a crappy day. Finally, they will backfill the rest of the trench and leave the end of the pipe exposed. By moving the trench box, they are all set to repeat the process. Now that we've seen how it's done, let's take a look at the productivity analysis and process model. Due to the nature of having a small crew, we felt our best way of measuring productivity was through the crew balance chart method. After you have all the excavating complete and you're ready to go, it takes about 25 minutes to lay and backfill one 16-foot pipe. We took a detailed log of the laborer's actions during this 25-minute period and put them in a graph. We found that each laborer is waiting 32% of the time, on average, that it takes to lay one pipe. After you've seen the process from a holistic standpoint, and now an individual standpoint, our process model merges the two together into a single page. We see the dynamic interaction between workers, machines, and materials. So now we ask the question, how do laborers stay safe? In this picture is a trench box. A trench box is used to prevent cave-ins or collapse during pipe installation. Contractors will put these structures up to help stabilize the surrounding walls of a trench. When working with plastic pipes, the risk is rather low but still present. Hazards include exposure to chemical fumes, sharp tool use, and the risk of heavy materials falling. Workers need to always have the proper PPE. This includes safety glasses, gloves, hard hat, steel-toed boots, and high-vis clothing. Transitioning from safety to quality, it is essential to highlight the significance of meeting ASTM standards for pipes. These standards ensure both safety and the high quality of our piping systems. We see that our pipe is constructed under ASTM D3034, which outlines the requirements for sewer pipes and fittings in non-pressurized applications. While talking about pipes, let's see how they're made. While we were unable to visit a manufacturing facility due to location constraints, we found some good videos of supplemental information. Here's an example of PVC pipe manufacturing process. PVC pipe is made by heating polyurethane chloride plastic and pushing it through an extruder as shown in the video. It is then cooled, bent, and cut to length for shipping. Let's have a quick discussion about typical errors and rework. Common mistakes during plastic pipe installation include improper alignment, incorrect fittings, inadequate support, and poor sealing. Let's close out the video talking about sustainable practices. PVC pipe manufacturing is extremely efficient, with virtually 100% of the PVC compound being used. It takes 4 times less energy to make than concrete pipe and half that used for iron pipe. There are no smoke stacks at PVC pipe facilities, and their product is completely recyclable.